is inorganic chemistry, and my lab is a synthesis lab. And we try to make the new solid-state materials, especially new superconductors. So, okay, let me introduce my lab a little bit. So this is usually we do the synthesis part. So we prepare our stuff in the glove box because we are working a lot on the air-sensitive materials. Yeah. So you can see my students working very hard. They prepare a lot of samples, and a lot of them are superconductors, and a lot of them are not superconductors. Okay. So after we prepare the sample, what we do is we seal the tube, and then we put the sample into the furnaces. So. We have the box furnace. This is the box furnace, and we have the tube furnace, and then we heat it to a very, very high temperature. This is the solid-state chemistry, the special part of solid-state chemistry. Because usually chemistry lab, you will see a lot of beakers, but we don't, because we do everything in a high temperature. So the temperature usually we go is 1,000 degrees Celsius. Sometimes we can get to like 1,500 degrees Celsius, even higher. So the elements will react at very high temperature. So this is the special part. We need these high temperature furnaces to work. Okay, after we make the sample, what we'll do next is we do the X-ray diffraction. Because we made it, we don't know what's that, right? So we need to use the X-ray to determine the phase. Okay, this is the small box called the X-ray diffraction. And we use this one to determine what we get. For example, well, I don't know what my students did. Maybe this is some new phase. Maybe that's a new superconductor again, you know. So this is kind of the basic routine synthesized way we are doing every day. And we also have 2 X-ray single crystal diffractometer on that room. And after we make the new phase, and we will determine the crystal structure, and we know what's that, right? And I'm very happy I got this Beckman Young Investigator Award because that's a lot of money. And and I use this money to buy a very fancy equipment called physical property measurement system. So I will put the new instrument in another lab. So my students can test the material's property immediately once they made it. Yeah, so that's basically what we are doing every day. And then we also do some computational work. So there is a computer workstation in another lab office. And what we are doing every day is we made a new phase, we try to understand it, we try to interpret it. So we calculate the electronic structure. So electronic structure, we cannot see it, right? We have to calculate it and interpret it. So yeah, so my group is kind of like a combination of experiment and theory, both. Yes.
Okay. And is that what we're seeing on the computer screen, the calculations?
So this one is not for calculations. It's in the other room. So if you want, I can take you to the other room.
And what is this one for? What do you do with the X-ray?
Oh, for this one, so we use this small X-ray diffractometer to determine the phase we made. So we make the sample, right? But we don't know what's that. Black, gray, who knows what's that? So what we do is we make the sample. So we make the sample, and now we don't know what's that. What we do is we make the sample and put it into the X-ray diffractometer, and then we determine what the phase it is. So if it's something new, we will get very excited, right? And then we will determine the crystal structure using the single crystal X-ray diffractometer. So another fancy one.
Okay.
So this is kind of like a very fundamental basic one. So we get some information. It's not very like a complete information, but we have an idea. And then we do the single crystal X-ray diffraction.
Is this telling you like the elements that make compose it? Or
Structure.
The structure. Okay.
Yes, the structure. Yes.
And that's like the structure, the form determines its function?
Yes, kind of like that.
Okay.
Yes.